Hello and welcome back to Machine Learning. I'm Chivita Christie, and in this video, we are going to, through programs, understand how you can explore numerical and categorical data. So first of all, if you have numerical data, you can do the following. You can find out the measures of central tendency. What are the measures of central tendency? They are mean, median, and mode. And you can also find out measures of data spread, which you can find dispersion using variance and standard deviation. And you can find the position using quartiles and interquartile range. And I'm sure you have studied all this in statistics before. Also, I have covered it in the previous videos, so this is very easy. We are simply going to implement it today and see how that works out. So to implement all that, we are first going to get our file. So this is the file we will be using, the CSV file. And you can see the CSV file is the AutoMPG file that we have used previously to train one of our classifiers as well. So you're pretty familiar, you must be familiar with this function already. These are the first 5 rows from the file. It contains all these values for MPG, cylinders, displacement, horsepower, weight, acceleration, model year, and origin, as well as the carbon. Now, pandas gives you a very simple function, a very simple function known as data.info. And this function is very simply just going to give you all the data types and things you need to know about it. Okay, so that means if you see it shows me that MPG is a float type and it contains 398 values. It is also non-null. Okay, it shows me cylinders is non-null and it is integer type. You can see here it is integer type. So that's what this, it also shows me the memory usage by this data set. Shows me how many floats are there, how many integers are there, how many objects are there. So this is the simple info function. Okay. Now let's talk about another function that gives you another detail. So you can see here it is known as the describe function. So this is data.describe. What this does is it takes all the numerical columns in your data and gives you all kinds of calculations, statistical measures of that data. So you can see it gives me MPG, which is a numerical column, and it counts how many values are there in it. It also counts the mean of all those values, the average, the standard deviation. This is the square root of variance. It will also give you the minimum value of all the MPGs. It will give you how many values are there in the first 25%, how many are there in 50%, how many in 75%, and it will also, so these are all the quartiles that it gives you. Okay. It will also give you the maximum value. You know that minimum, 25, 50, 75, and maximum, they together form the 5 number values which can help you to create a box plot. And 50% is essentially the mean value, as you know. Okay, so these details you get directly by just doing data.describe, and you can see that if the mean is high or if the standard deviation is high, you can know that that data is more dispersed, that the dispersion is also high. Now, you might notice here that horsepower does not appear, right? You can see here horsepower is not appearing anywhere at all. And the reason for that is that even though horsepower is shown here to be, if you see horsepower is shown here to be object, even though here horsepower is not an object, it's actually a number, right? So it should be either float or integer, but it's not. The reason for that is horsepower contains some values which are marked question mark because there is no data about what exactly this is. Okay, so because of these question marks, it is considering horsepower as an object and not giving you the data over here. So that is something called missing values. And we, of course, have to deal with such missing values. And we'll see later how you can deal with missing values. Okay. Let's now talk about box plot. So this is something else you can do with numerical data, which is to create a box plot. And box plots are nothing but a diagram that can show you the 5-number range in your of your data. So if you see a box plot, you can see the median is given right here on this thick line. This whisker of the box plot is known, it will show you the minimum and maximum value of the data. And the box itself will show you Q1 and Q3, which are quartile 1 and quartile 3. And everything else beyond these lines will be considered outliers. So these are all outliers present in your data. So this is what a box plot is. Now let's try to create our own box plot in Python. So in Python, we have this data set, first of all, which is known as iris. It contains different iris species. Iris is a flower, so it contains different kinds of species related to iris. And it has all these things related to that. So it has the sepal length and the sepal width, petal length and petal width. And based on this, you can classify whether it is iris setosa or something else. Okay, so that's the data we have. And this is something very we have used in the previous videos also, where we implemented some classifiers. So I'm sure you are aware of what this data set is about. Now let's try to create a box plot for this. So to create a box plot, we will be using the matplotlib and we will be importing the pyplot library from there. And from the iris data, I am getting the first 4 columns because I want to show create box plots for the first 4 columns, which are sepal length, sepal width, petal length, and petal width. And to create the box plot, you simply have to do plt.boxplot, pass the columns which I've stored in X, and then do plt.show, and that will give you all the columns. So you can see here now there are 4 columns, 1, 2, 3, 4. And for 4 columns, I have 4 box plots. So these are the box plots created. You can see in one of them, there are also outliers. Okay, and there are values given here. So you can see this one has a median of somewhere between 5 and 6, maybe 5.9 or something. Okay, the maximum value for this is probably 8. This one has maximum value of approximately minimum value of 4. So you can get to know a lot of things by using these box plots. And if you see very carefully, you will see here that here the box plot is bigger, the box is bigger, right? So when you see a bigger box, that means the data has more dispersion. Okay, so you have a more variety of data over here than over here, which is very small, right? So that's what a box plot does for you. You can also find outliers by using this code right here, okay? I'm only trying to find the outliers for the first column, okay? So for my first column, I'm trying to find the outliers. So if you use this code, you can see here, there are outliers right here and right here. You can see those because you created this, okay? So you can see your outliers. And you can also print the outliers. So I have printed the first outlier, which is 4.4. Now let's talk about histograms. So this is another thing you can do with numerical data. You can create histograms for them. So histograms can be of several types, and based on the shape, you can say a lot of things about histograms. So histograms can be symmetric and uniform, which means they follow the uniform distribution, and the shape will look like this. A symmetric and unimodal histogram will look like this, which means there is only one mode value, which means there's only one value that appears maximum number of times. You can also have a left skewed histogram, which looks like this. It is lower on the left side than on the right side. You can have a right skewed histogram that looks like this, which is lower on the right side than on the left side. So the values decrease so y decreases as x increases. And you can have a bimodal histogram, which, as you can see, has 2 peaks, right? Instead of one. This one had 1 peak. This one has 2 peaks. which means you will have true values in your data, which will be appearing maximum number of times. And you can also have a multimodal histogram where you can have several peaks instead of not just one or two peaks. So this is what histogram can show you. Let's create a histogram for the iris data. And to create a histogram, we are going to use the sepal length column. And it's very simple. First, you fetch the first column, store it in X. To create a histogram, you just have to write plt.histx and label. I want X label to be sepal length. So I can see here sepal length. And now I can show. So I can see that there are sepal length of 4.5 is available for at least 9 different species. Sepal length of 5 is there for about 23 or 24 species. So that's what the histogram shows me. Another thing you can do with this kind of data is to create a scatter plot. Okay, so a scatter plot will show you how dispersed the data is and how one variable is connected with another variable. So let's take a look at this. I'm using the iris data set again, and this time I'm using all 4 columns and placing them in X. And I'm also passing a column to Y, which is the target column. Okay, and while creating my data, while creating my graph, I am using the second column. So the second column is the petal length column, and I'm using the second column as my x-axis, and I'm using the sepal length column, which is the zeroth column, as my y-axis. So you can see here it shows x label and y label, petal length, sepal length, and those things are plotted here. This is what the graph looks like. So if you observe, you can see at least this much of the data is following some form of linear regression because it is moving upwards, right? So it does have some relationship, and you may call it a linear regression relationship. So that's how you can explore numerical data, by creating all these graphs and using the describe function to see the average and quartiles and medians and everything. Now let's talk about categorical data. Since categorical data does not have values because it's qualitative instead of quantitative, you cannot do much with it, but you can do something with it. So let's go back again to our MPG, auto MPG data set. And what you can do with categorical data is count the values. So you could count how many different types of cylinders are there, how many different model years are there. Okay, that is one thing you can do. You can also do something called cross tabulation. So what is cross tabulation? Cross tabulation is just counting for each column how many times the other column is appearing. So for example, here I have done a cross tabulation of number of cylinders versus model year. Okay, so you can notice here how it is done. So for creating a cross tab, you just have to call the cross tab function of pandas, which is here, and pass the rows and columns. So I want the rows to be cylinders, so I passed cylinders. The columns, I want them to be model year, so I passed model year. I can also give names to my rows and columns. So my row names are cylinders, I've written here, and column names are model year. And now if you look at it, this data shows you that there are 2 model years, 72 and 73. Both of them have a car that have cars that had 3 cylinders. And here as well, 77 model had a car with 3 cylinders. The 80s model also had a car with 3 cylinders. And for 4 cylinders, you can see that, for example, in 76, in the model year 76, there were 15 cars, different cars with 4 cylinders, and so on. So this is something you can do with categorical data.